Cool.
Okay, thank you. All right, so I think to disprove if that is identity or not is that we just have to put any angle in for t and see if it equals each other. So we could pick any angle on the unit circle, I believe, right?
So we're picking an angle for t, is that correct?
Yeah.
Okay.
So let's do like pi over 2 or something where sine is 1, because that might be easy to plug into the equation.
Okay. So how do we write that? Or how do you write that?
So I think we're plugging in for t. So we do sine of 2x equals 2 sine of pi over 2, which is 1.
So it'd be 2 times 1, which would be 2, right?
Yeah. And then, but I don't know if we can plug that same thing in for x on the other side.
I think so. I think that's what we're supposed to do.
And see if it comes up with the same thing.
Yeah, so if you did sine of 2 times pi over 2, you're just left with pi. And then the sine of pi comes out to be 0.
Okay, so that doesn't
Equal.
equal each other, so it's not an identity, right?
Right.
And then the next one says the following problem guides you through the answering the question. Find an equivalent algebraic expression for blank. Discuss each part and make sure you understand the process and can answer the questions. Different process, but we introduced you to how to use this type of problem is answered in calculus. Okay. That sounded weird to me. Question. Find an equivalent algebraic expression for sine times tangent, inverse tangent, or what do you call it? I don't know. X. So that's the question. Do we need to solve it or do it? Because then it says for the question given, what are you looking for? Like it continues on. Like I don't think we're supposed to solve it yet, right?
Right. I think it's saying that these are steps on how you're supposed to do it.
Okay. So we're not solving anything yet.
Right.
Okay, so for the question given, what are you looking for?
So we're looking for sine of tan negative 1x.
Okay. And then in your book, you will find a different process, but we introduced you to how calculus answers this type of equation. Given that x is a side length, the output of inverse of tangent x has to be an angle, right?
Yeah, because if you do the inverse of any of the trigonometric functions, you'll get an angle.
Okay. So we begin by drawing a right triangle and labeling each part. What do you mean? Do we know any parts yet? Or are we just saying like hypotenuse A and B? Opposite over adjacent?
Yeah, that's what I mean, I guess if tan negative 1x, so x is going to be the opposite side, right?
Yeah.
So x is the left side that makes the right angle. And then c would be our hypotenuse.
And then we don't know the third side then, based on just what we have.
Right.
Okay, so
So
and I think we use the like a squared plus b squared equals c squared formula.
yeah.
So we just would have x squared plus c squared plus something we don't know.
Yeah, it'd be x squared plus something equals c squared. So we have to figure out what that other side is.
That's when it says find the third side.
Yeah.
Okay. Okay. I guess it just has to be in forms of.
Um,
I don't remember doing anything like this in the homework yet.
yeah, I haven't seen anything like that either. Have you seen anything, Antonio? I'm not hearing you, Antonio. Can you hear him, Monique?
I can't. Okay. So we know x squared and c squared. And then
I'm trying to see if there's anything, any of the identities that would be able to help.
oh, that's good idea.
So no, we can't. So one of the Pythagorean theorems or identities is sine squared plus cosine squared equals 1. Or any of the, I feel like maybe one of those would help.
Oh, yeah, I guess since it's squared and tangents sine and cosine, so maybe there's a 1 in there somewhere.
That's what I'm thinking.
I think you're right because it would be I think unknown squared because you have to do so we don't know that one yet, but you could fit that in because it's sine and cosine and hypotenuse or whatever. So it would be 1. So maybe it's x squared plus, should we use another variable, or would it be 1, do you think?
Well, our unknown would be c. So c would be the hypotenuse. That's the unknown part.
Oh, okay.
So I'm thinking x squared plus 1 squared equals c squared.
Oh, that would make sense, especially if you're using that Pythagorean identity.
Yeah.
Squared plus 1. So you're saying like x squared plus 1 squared, which is 1, equals c squared?
Yeah. And then you end up solving for c. So when c equals square root of x squared plus 1, but it's going to be plus or minus because you took the square root of it.
But it can't be negative because it's a triangle, right? So it's just the positive one?
Right. But I guess I think I remember back in like the earlier lessons that they kept the negative part still.
Oh, okay.
Because I think that would help you know whether or not it was a triangle or not.
Oh, okay.
Um,
So is that the third side then, the plus or minus
yeah.
x? Okay. So now next part is, oh, you can find sine theta. Sine theta equals,
So sine is opposite over hypotenuse. So what it would be is sine of x would be x over plus or minus the square root of x squared plus 1.
okay, that makes sense. And then last it says the equivalent expression, that first part equals sine theta equals that answer then, right? Plus or minus x over square root x squared plus 1.
Yeah, it's the same thing.
Okay. So just a long version of doing the same thing. So then factor the following trig expression. Sine to the fourth x minus cosine 4 to the x. So this one I think we can, oh, and it would be sine 2x plus cosine 2x and then minus, right? Another one?
Yeah, because they would cancel out. Or the middle, there would be a positive sine or sine squared x cosine x
Mm-hmm.
squared and then a positive. So sine squared x minus cosine or plus cosine squared x times sine squared x minus cosine squared x.
Okay.
And then you could factor out the second part, the minus cosine squared x, into the sine x minus cosine and the sine x plus cosine x.
Oh, yep.
Because it's like completing the square almost.
Yeah, but the other one can't be broken down, right? Because it's the plus.
Right. Do you want to try backing out and coming back in, Antonio? Or it says you're on mute. Okay, now it says you're not on mute.
Can you hear me now?
Yeah, but it's like low.
Yeah, really low.
Trying to figure out what's going on here.
Or we can still hear you, you just have to speak up.
So I think for that question, that one that we just did, then I think that's as far as we can go with it, right?
Right.
Because we're just factoring, we're not solving, we're just factoring it out.
Yeah, we're just breaking it down.
And then the second one was cosine 2 alpha times, is it times tangent a minus 2 times cosine a minus 3 times tangent alpha?
Yeah.
Like how So we're just factoring.
Are you guys on the second one on number 3?
Yeah.
Okay.
Did you understand the other parts, Antonio, or do we need to go back over it?
No, I got him. I was trying to get this fixed, so but I got what you guys were saying.
Okay. So I'm looking at this as two equations, like separating cosine 2a tangent a minus 2 in one, and then the other one cosine a minus 3 tan a, because then we can factor out tangent, right?
Yeah, I'd pull a tangent out of both of those for that whole thing.
So tangent x.
Cosine squared a minus 2 cosine a minus 3. Yeah,
And then you
and
can
then
factor out.
yeah, where you'd get cosine a, you'd get minus 3, or cosine a minus 3 as one factor, and then the other one cosine a plus 1.
So then it would just be tan a times cosine a minus 3 times cosine x, or a plus 1.
Yeah.
And then we're not solving, we're just factoring.
So that's it for those two.
And using the identities you have learned and the different strategies, verify the following identities. It is suggested that you spend about 5 minutes considering them individually, then work together to do the verification. This will give the opportunity to formulate a plan on your own before being influenced by your team members' thoughts.
Okay, I'm gonna run to the restroom real quick.
Okay.
Okay.
These seem to be pretty easy, but they look really complicated to me.
Yeah.
That where it's like, but it breaks down and it's like, oh, okay.
It's good to have the identities right with you.
Yeah. We're supposed to memorize them, right? If they have the.
I think so.
Okay, so this will come up first one.
Okay. Did you guys start this one or no?
Oh, we were just looking at it and then we were going to come back together, but we can work together if you want.
Okay.
We just want to do it together, so save on time.
Yeah. Okay. Might as well. Okay.
Okay, so that first one. So I think that first sine 2 and then x and the CSC, I think that part, because it's 1 over sine. So I think those cancel out, right?
Yeah, so those cancel out. So you're left with, or it reduces down to 1.
So it'd be 1 minus 1 and then sine 2x, that last part you can't do anything with yet, right?
Yeah. So then you're left with 1 minus 1 plus sine squared x over cosine squared x. And then the 1's cancel out because it goes to 0. So you're left with the sine squared x over cosine squared x, which turns out to be tangent squared x.
Sorry, guys. I'm really tired today.
No worries.
And then the next one is, you guys have it, or do I need to say it out loud? Cotangent x times sine x minus cosine 2 x and x. And I can't get them in my head. It's cosine over sine, right?
Yeah, since it's cotangent, it's the inverse.
The cos over sine times sine x, which will cancel out the sines. Minus cos x.
And then secant is 1 over cosine as well. So the cosine squared gets canceled out once, and the secant gets canceled out. So then what you're left with is cosine x minus cosine x, which ends up being
0.
0.
Cool. Q tangent squared x equals 1. We call it cosecant. So it's CSC is.
Okay, so this one, so you have to have a common denominator. So you multiply each one by the opposite denominator on the top and the bottom. So the first one comes out to be
Plus 1, cosecant plus 1.
yeah, secant x plus 1. And then the common denominator, it's going to be secant squared x minus 1. And then the second part, the second top is going to be minus cosecant x minus 1 in parentheses. So you have cosecant x plus 1 minus parentheses cosecant minus 1 parentheses. And then if you distribute the parentheses over and just simplify it a little bit, you get cosecant x plus 1 minus cosecant x.
I just found it.
Yeah. And then, so the cosecants cancel out on top. And then,
the 2, right?
yeah, so they combine together to get 2. And then the bottom, so if you use which identity was it?
I think it's the I can't say that. Pythagorean.
Yeah,
that one. Because 1 plus x equals so CSC 2x.
Yeah.
That would leave that with cotangent 2x, right?
Yeah. And then if you switch, so if you break this apart, if you do 2 times 1 over cotangent squared x, 1 over cotangent squared x turns out to be tan squared x, which is what we started with originally.
Okay, so that is not going to be them. Cool. So then the last one, We have to do both sides?
Yeah.
Hmm.
Or I guess, oh no, I guess we're just solving the right side.
Right side? To see if it matches the other side, right?
Yeah. So with the negative x in the parentheses, what that just does is it turns the whole sign negative. So if we reduce that real quick, so what it comes out to be is it turns out to be 1 minus sine of x instead of 1 plus sine of negative x.
Yeah.
Over cosecant x.
But okay.
And then if we have to get 1 minus sine squared x, we would just have to multiply it by 1 plus sine of x so that it comes out to be 1 minus sine squared x. So you multiply the whole thing by 1 plus sine of x on the top and the bottom.
Okay. So that leaves 1 minus sine squared x over. Can't have cosecant and can you?
Well, so if you're multiplying cosecant, so if you distribute it to the 1, you get cosecant. And then multiply by sine, since cosecant is 1 over sine, it turns out to be 1.
Okay.
So you get 1 minus sine squared x over cosecant x plus 1. And then what we would have to do is we'd have to go backwards using the even and odd identities. So if we wanted to get from where we started, so 1 minus cosecant of negative x, we would need to change everything on the bottom to negatives or the opposite. So it'd be negative cosecant of negative x plus 1.
Okay.
And then we would just rearrange it so it gets back to the original form. So 1 over sine squared x over 1 minus cosecant of negative x.
But that one is an identity as well.
Yes.
I think that's it.
Okay, not bad.
Yeah.
I guess I'm still confused on that the triangle one. Do you understand that at all, Antonio, on how to get that other side? Because I just took a guess, like using the theorems.
I'm not sure. I haven't gotten this far into the homework. I've been slacking on the homework this week.
Well, the homework usually for like this first meeting is like the first one, first or second, and I did both of them, and I didn't see any homework problems like this.
Interesting.
Or even less than 1 or 2.
Huh. Okay.
I mean, I think how we did it makes sense.
Uh-huh.
But I guess did someone check the answers along the way?
Yeah, I was checking them. And it all made sense. We got them right.
Okay.
It's just kind of just like understanding it fully, but
yeah. I wonder if any of the resources, because I didn't look at any of the resources that she sent. I wonder if something in there it has that.
Maybe that's where we find it. I just pulled up all the identities.
Yeah.
But okay.
I did. Yeah, I was gonna say I did put notes out, but I didn't see anything in there for triangles.
Yeah. Okay.
We're still meeting tomorrow, right, for the second one?
Yeah, we have another group quiz, I think.
Yeah.
Yeah.
Okay. So should we just do that tomorrow then?
Yeah, I can't do it any other day, so.
Okay.
If that doesn't work for anybody else, then I'll just miss it this week.
Okay, that'll work then.
Okay. I'll just submit this in for today. Is that cool?
Yeah, that'll work.
It's easy since I just do it and then I just print it. So.
Okay, sounds good.
All right.
All right, see you guys tomorrow.
Yeah.
See ya.